Welcome guys, so keep solving our physics subject GRE. So 75, basically you have two panels and what you ask about the heat flow and the ratio of the heat flow. And this is the general physics question. Basically heat flow depend, you need to use the so-called Fourier law. So so-called Fourier law, the ratio of the heat basically depend on some constant divided by the gradient of the temperature. So basically, it's the change of temperature defined and the distance you need to transition, the distance from different temperature. Okay, so basically, for A, if this is A, this is B, then QB divided by QA, just energy, the temperature difference. Oh, and then there's a thermal conductivity. If the thermal conductivity of glass in air is 0.8, and let me see, and 4 millimeter thick, and this is 2 millimeters, and ask about the ratio. Okay, so from this one we get basically QB over QA, just KB LA KA LB. We assume the temperature is same. So basically we have this. Okay, so QB over QA is 1 over 16. So QA over QB basically is 16. So the answer is D. Okay, so 76. Gaussian packet for the this is from mechanics. So first one, average momentum of the wave packet is 0. This is definitely not correct, right? Because the Gaussian distribution, their mean can be arbitrarily large. So the mean not need to be 0. The width of the wave increase with the time. This is correct. Okay, the amplitude of wavefront remains constant with time. Maybe. So the force is the arrow, the wave packet is momentum space, the wider is coordinate space. This is the common sense. This is basically the uncertainty principle. So we know that the first one definitely not correct, and the first one is nearly correct. So the answer is must be B or D. Must be B or D. Okay. And I also know that B is correct. So the answer is oh, so the answer is B. Okay. Like the amplitude not need to be constant. Because when you spread, right, when your Gaussian will spread. So amplitude can be decreasing and the width start to increase. Okay. So 77, this is the easy quantum mechanics question. Basically, ask about the energy of this type of Hamiltonian. Okay, so this is basically S1 dot S2. You can write down as S1 plus S2 squared divided minus S1 squared minus S2 squared. And then F on the quantum state is S1 squared and S2 squared operators basically can have fixed value for it, which is this one. So that means these these total angular operators needs have, so this is minus J, right? And the J is positive. So that means if I want the total this term to be as small as possible, I will want this to be largest as possible. So what is the largest for largest term for this one? So basically when S1 plus S2, then the total angular momentum is L plus L times L plus 1. So it's L S1 plus S2. and then S1 plus S2 plus 1. Okay, so the answer is just D, just D. And by the way, I should divide it by 2 because so the cross term is 2S1 dot S2. So the answer is D. Answer is D. Okay, so 78 and basically common sense. The N type means that there are more electrons, so there will be electron into a conduction band, and this is called donor. So the answer is E. The answer is E. Okay. So 79 for the ideal diatomic gas is the thermal equilibrium, the ratio of heat capacity at constant volume to very high temperature. To that very low temperature is what? Okay. So this is the common question, which I want to say that in a usual temperature, a diatomic, basically your CV just 5/2R, and why is 5/2? Because you have three rotations, 2 rotations plus three translations. So you have 5 degrees of freedom, and each one will give you R/2. But for a very high temperature, you will become 7/2R because there will be vibration comes in. Okay. And for the very low temperature, basically the diatomic it looks like a monatomic because there's no rotation. Okay, so to very high to a very low, which is 7 over divided over 3. 7 over 3. Okay. Okay, let me see. I think it's enough for this video, and I will see you guys in the next video. Be sure to subscribe to my channel.